Alright, we're going to start a pretty lengthy unit on transformations of functions. We're going to be working on this for quite some time. But before we start on the transformations, let's just learn about different types of functions. Well, there's a linear function. A linear function is, exactly as its name implies, a line. And let's just underline the L there, so we can help remember what a linear function looks like. And a linear function would look something like, if these are the axes, like that. There is an absolute value function. Let's underline the V there, because that's exactly what an absolute value function looks like. It looks like a V. And if we have a set of axes here, then an absolute value function would look like that. Here's a quadratic function. And let's underline the U there, because that's what it looks like. It looks like a U. And a quadratic function would look like that. There is a square root. Let me do this like this. Root. And we're going to underline the R there. Maybe not just square root. How about radical function? Same thing. Either square root, radical, but again, underline the R, because that's what the graph is going to look like. And a square root function looks like that. So an example of equations would be y equals x, y equals the absolute value of x, y equals x squared, and y equals radical x. So what we're going to do with these four types of functions, we're going to change these equations around and see what happens to their graphs. So these are going to be introduced as parent functions. These are parent functions because all of the functions begin looking like this. Then operations are performed on the equation which change the shape of their graph. So as we change around the equation, we should recognize what happens to the graph, and conversely, as the graph changes, we should be able to recognize what happens to its equation. So using these four functions, we're going to be moving them around. So in order to do that, let's just recall some facts that we learned in geometry and list the types of transformations. Well, there is a group of transformations called reflections. There is a reflection over the x-axis. There is a reflection over the y-axis. And there is a reflection over the line y equals x. The rules for these reflections. If we're reflecting over the x-axis, an example, let's say we had an order pair here, which was 2, 3. If we're reflecting it over the x-axis, it comes down there. So what happens? The y value became the opposite sign. So the rule for this, any xy becomes x negative y. If you're reflecting over the x, make the opposite value negative. If we were to reflect over the y-axis, well, again, let's use that ordered pair 2, 3. If we're reflecting over the y, then it becomes that ordered pair. What happened here? The x value changed value. The y value is the same. It just became the opposite sign for x. So any ordered pair xy becomes the ordered pair negative x, y. is simply making the opposite variable negative. And we're familiar with this rule. We've been working on this for a couple days now. This is the rule for an inverse function. So any ordered pair xy becomes the ordered pair yx. Interchange x and y. In addition to reflections, there are translations. A translation is a shift or slide. Nothing is happening to the shape of the graph. It's simply being picked up and put somewhere else. So an example here would be something that looks like that. What if it looked like, oh, broke my if it looked like that? Well, the only thing that happened here, the graph shifted to the right, therefore it's a translation. Oh man, this pencil really keeps... So we have dilations. A dilation is if you're changing the shape of the graph by a vertical or a horizontal factor. So now what you're doing is multiplying by something. There is a dilation in the y direction and a dilation in the x direction. And the way you could determine what's happening, which value is being multiplied, x or y. So these are the basic transformations that will be operating on graphs: reflections, translations, and dilations. Let's work on a linear transformation. So let's plot the graph of a linear function y equals x. So let's set up an axis and plot the ordered pair, the graph y equals x. Y equals x is a linear equation with a slope of 1 passing through the origin. So here's y equals x. Now let's change this equation around a couple of times and see what happens to the graph. What if we mapped it onto y equals x plus 3? Let's plot these ordered pairs on the same axes and determine what happened to the graph. So this is a linear equation passing through the y-axis at 3. It's got a y-intercept of 3 with a slope of 1. 1, 2, 3. And it's got a slope of 1. Rise 1, run 1. Rise 1, run 1. And here is our graph. Man, again, the pencil. So this is y equals x, and this is y equals x plus 3. So if you can see what happened, the graph shifted up 3 units. It went up 3. Every single ordered pair went up 3 units. So this would be a translation of 0 in the x direction and 3 in the y direction. Now, let's see what happens if we have y equals x being mapped onto y equals 2x. See what happens to the graph. Set up some axes here. So y equals x looks like this. So here's our graph. And let's see what happens if we plot the graph of y equals 2x on the same axis. Well, now they've got a y-intercept of 0 plus 0, but now it has a slope of 2. So starting with the y-intercept, we're going to go up 1 and over 1, up 2 and over 1, up 2 over 1, up 2 from here, up 2 over 1, up 2 over 1, up 2 over 1. So if we plot this graph, this is what we're going to have. So now, what happened here is that the original graph, y equals x, was stretched towards the y-axis. It was stretched towards the y-axis with a factor of 2. So this is a dilation of factor 2. Okay, now let's work on a reflection. Y-axis, x-axis, and I'm just going to plot a random graph. I'm going to say we have something that looks like this. I'm not going to have an equation for it. I'm just going to reflect this graph over the x-axis and the y-axis. So if I want to plot this image, the image of this graph, let's call this graph f of x. If we want to sketch f of negative x, now what that's telling me is that the x value is becoming negative. That's my cue to take every single ordered pair on this graph and make all of the x values the opposite sign. If I want to make all of the x values the opposite sign, this ordered pair, -1, -2, -3, -4, -5 of an x value would now have an ordered pair of +5 as an x value. So this is the ordered pair -5, -3. That means we're going to have the ordered pair 5, -3. 1, 2, 3, 4, 5. And there were 4 ordered pairs over here that we're going to flip. So now this is the ordered pair -1, -1. So that's going to be right there. This x value is 0. Can't change the sign of that. This is the ordered pair 1, 3. So make the x value negative. -1, 3. 2, 2. -2, 2. And we're going to do the same thing to all of these x values. So here is our graph of f of negative x. Conversely, if we want to sketch negative f of x, that's just asking me to make all the y values negative. Since we're making all the y values negative, that will be a reflection over the x-axis. This is a reflection over the y-axis.